Hello everyone, welcome to another Google Cloud session. In this session, we are going to see the lab. In this lab is going to be explaining an image classification model with Vertex AI, explainable AI basically. Okay, so my name is Suresh and without any delay, let's get started. So let me start the lab and I'm going to use my credits. So I'm going to use 5 credits for this lab. So in this lab, we are not going to look into the more detailed analysis or topics about this, all the GCP, Vertex AI, Workbench or instance or TensorFlow model. Here we are going to only execute the task that is provided in this session. So let me open this in a new cloud, new window. Basically, I opened it in the Cognito window. You can see it in the right side. So the tasks provided is to clone the repository and then use the TensorFlow model for the explainability. Okay, so the learning objectives would be build and train a custom image classification model, deploy it and serve predictions, and visualize features and attributions. So task 0 is setup and requirements. I hope I have done everything. Okay, let's enable the notebooks API. So go to navigation menu, API and services and library. So here search for notebook API, select the notebooks API and enable. Okay, so let's wait for this to get enabled. You can see this in the navigation also, notebooks API. Okay, so let's move on to again the navigation menu and let's move on to Vertex AI and Vertex AI dashboard. And I will say enable APIs here. I don't see anything called enable all APIs, so I'll just enable APIs. So this is checking and Vertex AI API and just enable it. So we'll get to the Vertex AI Studio features. So here we can check the progress once this is enabled. Let me check in the notification. Yes, I see this is enabled. So let me check the progress. So assessment completed. So looking good. Now let's move on to the task 1. So in Vertex AI, we are already in the Vertex AI and select the workbench here inside the notebook section and create new and use the default zone as your central 1C. And let me name this as lab workbench and I will leave others as default. If you want to see the advanced options, you can see the advanced options as well, but I will leave everything as default. So let me continue here. So you can see the environment, there is a Jupyter Lab 4, but I will go with the Jupyter Lab 3 itself. Continue, and you can see the general purpose machine type and its configuration of memory and CPUs. Okay, I will leave everything as default and you can see about the disks and encryption and the networking properties and IAM and security and finally the system health. So by this I'll just select the create. So this is going to take 2 to 3 minutes to get started. So once I get started, I will open the Open Jupyter Lab. So I'll wait for it. Okay, so the lab got created and it took about 2 to 3 minutes. So let me open this Open Jupyter Lab. In the meantime, I'll just check the progress. So looking good. Now let's move on and get this cloned and we'll do the installation. Okay. So if you want to see about the lab workbench and its details, you can just click on that click on the Vertex workbench and you can see the uh, information about the system that we have just fired up, and you can see the disk and security software and security and its other key metadata and its health. You can see everything is healthy, and monitoring and few other logs if you want, if you are interested. Okay, everything will be available. Okay, let's move on to the Jupyter lab. I don't need this, but I'm not sure. Okay, fine. Let me select the terminal. Okay, so the terminal is opened, and now in the command line I'll just paste this and hit enter. So this is going to clone the repository and cd to the folder name ASLML immersion. You can see this is getting downloaded and all the files are getting downloaded and exporting the path to local bin and then making the install. Okay, so double click on the director and ensure you can see the contents. This one will be last. Since this download will take about 2 to 3 minutes to my previous installation, I have seen it will take a lot of time to download, but basically at around 5 to 6 minutes it is going to take. This is going to collect all the details first and then start installing. Okay, so if you want to see what is available in the make file, let me navigate to this and you can see make file. So you can see these are all the requirements. So these are all the requirements that is getting launched, installed basically. Okay, so let me enable this. I don't know whether this is required or not, but to be in safe side, I will enable this as well, because this is not going to cost me anything because I'm already using some credits. So I just enabled it, but this is not required as per the session. So I'm not worried about the deprecation, and I'm not worried about the warnings at this point. I'm just following the instructions that is provided in the lab section. Let me try to check the progress. We'll see whether the progress is done or not. Okay, this is done. So basically it should show 100% at this point. Let me wait, and also we'll get into the task 3. Here is the actual work. Our work is going to start. Okay, so I will leave all these files to get downloaded. So you can see the progress is 100%. It's already 100%, but our actual work is not yet started. We need to get into this folder, and from there we need to execute the Python code and see the actual exercise in it. So this is basically for responsible AI for developers regarding the interpretability and transparency. Okay, we'll look into that, what is needed. Okay, so in the meantime we will navigate ASLML immersion. Okay, this is the first folder, and inside is notebooks, and inside responsible AI, here explainable AI, and in solutions XAI Vertex. Let me open this, but I'm not going to execute at this point. We'll see. So this is getting installed. It is taking time. If you want to see what is exactly inside the files, you can clone it on your own with this URL. Let me show the URL. Yeah, you can clone it at your local repository, and inside this you have a lot of files where you can go and update it, and you can go and have a look into that. But as I mentioned in earlier, I'm not here to explain each and every line of the code. I'm here only to explain how this lab works. Okay, I think all the installations are completed. So let me get it here. Okay, here uh, in this IPython, this Jupyter notebook, you can see what is, you can pause the video and get the information you needed. So first let me import the necessary packages and files. Let's optimize it to available CPU instructions. Okay, fine. And this is the configuration of the Google Cloud. So we know the project is created. Now this one is going to create the Google Cloud storage bucket if not available. So bucket is also, it's already exist. So bucket is already exist. Fine. And now exploring the data, flower set from TensorFlow dataset. Let me open this flower set data. Okay, now you can see this is copying all the TensorFlow data, and wait until this process is completed. This is still getting downloaded and it is taking all the files that is needed. And also you can check whether this is busy or not. If it is busy, then the operation is still going on. So what I recommend is pause the video and understand this code. This is very important. That is the part of the exercise. If I am going to each and every line, then it will take about a hour and 1.5 hours. But here the intention is not about explaining the lines of code and how to write the code. Here the code is already provided in the lab session, and we are going to execute. If you want to understand really, then either you can clone the repository to your local and then understand what this code about. Yes, you can just watch this and how to execute it in the Google Cloud system. Okay, so but reading and understanding about the code is the actual work, not only the execution. Okay, I hope you better understand about it. Okay, so let's run the training data path as well as, so this is the training data path. We received it. There are 13 objects, and another one is evaluation data path. We have 3 for evaluation. Okay, so the split is done. Now create ingest functions and visualize some of the examples. So all this image size, batch, and all the daisy dandelions, and this is the label of the flowers. And I strictly want you guys to pause the video and understand about this code. So now you pause the video and understand from half of it till this load TF records. Okay, now next set is complete. Okay, so load test here also. From here you can pause the video and understand about this code, and finally displaying the code. So let me run this code. Execute a start aborting this not okay. This is some kind of error. I have to check on that. But there are some sample sunflowers, dandelions, sunflower. Okay, there are something is happening. So let's make a directory for the trainer. Now let's build a training pipeline. So here I can see a trainer, and you can see there is a folder got created as flowers with the trainer. If you select the flowers, there is a trainer and there is a init. You want to see. So basically in the init, there won't be any files at this point, but once, let me close this, once I run this code, this Python code is going to write in that file. Okay, so now let me run this code. This is writing. Okay, now let me again go back here, and so there is a train.py file got created. Okay, so this is the file. Now you can see, pause the video and understand from the line 1 to line 45, 40, 41 to 90, and okay, yeah, rest of the code 91 to 94, rest of the code. Okay, let me close this, and the writing is done. See, there are some models has been built in this section. Okay, so now test training application locally. Okay, let me run this code. Basically this is our local training, and you can see trainer or train regarding using the training validation and evaluation data, and the training examples are 10, only one epoch. Okay, this is getting trained. Let's see what output we'll be able to get. Okay, there is a loss of 2.26, accuracy is for 0.4, value loss, value accuracy, and 16 seconds per epoch. Exported trained model to local test training. Let me check whether I can see some. Yeah, here you can see local test training, and there is a files assets. Okay, you can see that there is a saved model.py. Okay, now I am going to create another file .setup.py, and you can visualize this in flowers folder. Inside flowers folder, setup.py. Basically this is going to write from setup, find packages and setup, and all the details. Now batch cd flowers python setup. I don't know why the standard file not found should be one. Okay, this is just a warning. I don't know whether that is going to face any issues in the future. Let's try it out. Now we are updating this into the Google Cloud storage, and with the buckets by name /flowers, and the operation is completed. Okay, now you can see this. You can pause the video and understand about this Google Cloud AI custom job created. Now we are going to create a job name, and we are going to train with all this information. Shift enter. Okay, using endpoint, custom job is submitted successful. Your job is still active. You may view the status of the job with the command. Okay, or continue streaming the logs with the command. Let's see this job. Let me copy this and put it in a terminal. Let's see whether in terminal it's able to see the process. Yes, you can see the job status pending, and all the other details or skills. There are number of 15 epochs. Okay, let's try this in another terminal, streaming the logs. So this is going to take, actually this is going to take about 5 minutes or so. Okay, so let's copy this and let me go to this terminal and then let's see the streaming of the jobs. I'm just checking whether I can see it here. Let me try to search for the go to Vertex AI. I'm just checking whether I can able to see the job that is running in the UI itself. So let me go to the dashboard. I have enabled all the recommended APIs. Let me see in training. Unfortunately, I couldn't get anywhere. Let me check in the pipelines. There are nothing here. Let me check where it is running. Let me use this command back. And this should be in the custom jobs. What I'm trying is I'm trying to see the jobs running. Okay, here it is. We can see in the model development, training, and custom jobs. Okay, this is the flower. This is created just a few minutes ago and it is still status is pending. Okay, let me select this. Still in progress, status is pending, and it is still in progress. Package locations, we can see all these details we just updated. Let's see the logs if needed. So logs explorer, you can see Vertex is provisioning job first image. Take a couple of minutes. Okay, this is 24 seconds. Okay, so you can see the information what is provisioning job for running frame first time. Usage might take couple of minutes and subsequent runs much faster. Okay, so this is still taking time. Let me go to this job. So 3 minutes gone. So basically how much time they are talking about. So I think it was talking about 5 minutes. Let's go back to the Jupyter lab. Inside the lab, model training will take 5 minutes or so. Okay, so what I will do is like I will stop the video or pause the video for a few more minutes and we'll come back and check. Thank you. I'll come back once this is done. Once this is process is get completed. Okay, so I'll wait for this process status to get completed. Okay. Now if you see, it's almost it is showing 29 seconds. Earlier it was in provisioning state, and if you see the logs, this is where this service got certificate and rest of the things started. Basically previously it was in different state, like provisioning state and running state. Now it is in training state. You can see the status of training. So let's see whether I can get some more information about it. And now this is the status is training. Okay, let me double check over here. And in the terminal, you can see the job status is still pending. Let's see what is the job status for now. Now the job state is moved to running. Earlier the job status was in pending. So I will wait for this the running state to complete, because in the lab they have mentioned about it will take model training will take 5 minutes or so. You have to wait for training to finish before moving forward. Okay, that is the reason I'm not getting into the next things. Okay, let me try to check the logs. Okay, now you see I mentioned about G-Cloud AI custom jobs stream logs for the project. Let's see how the streaming logs will coming. So using endpoint. Okay, now you can see the logs. Now this is third epoch. It is evaluating. So there are total 15 epochs. Now you can see here we have mentioned about the number of epochs 15, and the batch size is 32, and the training samples of 15,000 15k. Now the third epoch is in progress, so this is going to take some time. Okay, so let me wait and I will show this epochs once this is done. Of course this is not part of the lab, but we are getting some additional time and we will evaluate most of it. We have a long way to go. So basically once we're done with this, then we will be serving and then predicting the things, predicting the data. Okay, so let me keep the terminal open. Okay, now third, fourth, fifth is done. Now it is in sixth. Okay, once this is completed, I'll resume back. Okay, now you can see there are some epochs has been completed and it is getting done. Okay, so epoch 15 by 15 is done, and also service job is completed successfully. So let me close this trial and let's get into this logs explorer. And here we don't need much things. Okay, so let's get into the custom job and see here. Okay, now you can see the status has finished. So this took about 6 minutes and 30 seconds, but for provisioning it took about 10 minutes. So there is a difference. Okay, let me close this and let me come back to this. Now this step is done. Now serving functions to image data, you can go through this information about this. Now using the model, let me run the load model. So note, if the directory does not exist in your model, it is not finished. Please wait the training to complete. So model is done. Now let's see the summary of the model. Yes, now we have the model. So the model is having about sequential model and the dense, okay, and total params and the trainable params and non-trainable params. Now let's get into this input regarding the pre-processing, about the signature specification and all other details. So let's see whether I can, yeah, this is okay. Yeah, now this is the complete program that we are going to run. So let me run this and you can see some information, and the program is still running, and there is some deprecated course is also available, but we are not worried about it. Instructions for updating, function update. So sets return in this model, flowers, this is in cloud storage. Let me get into the buckets, and here, and inside the flowers, and there is a model and assets. Anyway, this is completed. So now get the serving function signature. Again, if we let me run, so this is going to get the model input and model output. I'm not going to read everything inside this, and we have the serving function output as output 0 and model output input name and model output name. And now explain the parameters. Okay, integrated gradient attribution, step count is 50. Let's see the parameters here. Now let's upload the model. Note, this may take few minutes to run. So you have the input tensor name and output tensor name and all other details. And now let me run this code. Now this is creating the model. Let's see whether we will be able to see this in this area. Model registry window. So inside the project, location, central, models and operations. So this is going to take few minutes to run. So I will leave it as is. Just a quick check here. The step is not yet completed and it is running for almost 10 minutes. You can see it is still running almost 600 seconds. So I have to wait until this is get completed. Okay. So let's deploy the model once this is getting completed. Okay, I'll wait for the model to get. So let it run. In the meantime, I'll just try to execute this one as well, and we'll see how this is going. I'm not sure whether this has to be continuously running or it should stop, but I also took so I wanted to see whether this is going to run after this. Okay, now there are two cells executed. Let me wait. So prepare the request content. Because I'm running out of time, let me see how much time I left with this exercise. I just have only 30 minutes, so I don't want to miss out the things. So what I will do is like I will run all the code lines, and we'll see how fast this git generates. Okay, and in the meantime you can pause the video and understand the code again from here. So this is where I started. Now the previous step is completed. So this is where I stuck for almost 10 minutes, more than 10 minutes. So creating the model. Once this is done, and this is the end point of this model that is going to be get deployed, and with one minimum replica and one maximum replica count. And once this is done, preparing the request content. This is how I initiated it, and read image and base 64. Okay, and this is the last code, I guess. You can pause the video and understand this code and show. So I will just run this as well. So total 5 cells I have executed. So this is taking some time. So let it complete. Once this is complete within this 30 minutes, I will just come back here and I will explain this. In the lab, I just saw this code is failed after 900 seconds. Okay, let me show you the explanation. So you can see this is the stage that we wanted. And here you can see there are some traceback operation not complete, and it has been waited for 900 seconds. There is some exception, and I'm sure by this time we will not be able to resolve all this. Okay, so operation did not completed within the designated 900 seconds. So I'm not going to change anything, but I wanted to repeat the same step. So I am going to initiate this again, and let me see what exactly is happening. Either this could be because of the servers are down in the overview, I mean in the agents, or during the provisioning time. At this point I'm not sure about it, so I will again run this code and see what happens. If again this fails, then definitely we need to relook into this code and then get the update. Model name is flower classifier version 1. So you can see there is a training classifier here, but I'm not sure why this is getting failed. You see there is a model deployment. The version 1 is created, but nothing is available over here. So this type is imported. Again, this is going to take, I believe, 900 seconds. Let's see how this goes. So I believe, I'm not sure whether this is going to work, because in custom job I'm seeing one class fare, and what I will try to do is, like, I stop this code and let me run this. Even though there were some errors, I'm just trying to deploy this model. Let's see whether I'm able to deploy it. Checking. So everything is looking good to me. Artifact location. This model was imported. In order to test the model, you need to deploy it. Okay, there are two. I'm not sure whether this is going to work out, guys. Let me see how this goes. I don't know which version is this one is going to take. Okay, we have still 18 minutes left, but if you see, for the first created, which was at 8:05 p.m., that was not working, and the deployment model which we executed, the second one, it took the latest one which was created on 8:06 p.m. Okay, so when I select the classifier version 1, and when I see the deploy and test, here I'm seeing this is the getting deployed. I'm not sure this is going to work or not, because I don't trust this model, because there was could be some corruption happened during this cell execution. Okay, because I did say change it some splits, so I'm not sure whether this is going to be successfully getting deployed. But anyway, if there is a luck, you'll be able to see this deployment will get successful. Okay, even if it is deployment is successful, I'm not sure about the predictions, because of the messed up few steps ago, because of the timeout error and those things. Okay, uh, I'll wait for this deployment status to get completed, but here there is a catch. We have left only 16 minutes, so anything could happen. But in the meantime, what I will do is, like, I will just show the other steps in the meantime, or you can download it from the repository. You can switch back to earlier in this repository and go and understand about this lab. So this is the repository, and this is the location of the file. It does the again, repository is available in this git clone method, and the file is available here. In this file, after the deployment, there are a couple of data sets we will load and test and train, and read the image and base 64 encode, and finally we will query the response to get predictions and feature attributions. And we will use matplotlib for visualization. Okay, so let me wait again until this model get deployed. I have left very less time over here. Okay, we'll pause the video. Okay, if you see this last one took about 779 seconds. Okay, so this step number 23 got completed. That's what I could see here. Let's check in this code. Yeah, here we can see the status of active. This is in Flower Classifier version 1. So we left only 6 minutes. We'll try to get the predictions fast. And what this says, executor start aborting. This is not indicate an error. You can ignore this message. Okay, invalid, or you must feed a value of a placeholder tensor with d type string and shape 3. I don't know what this is. This is pretty messed up. Let's try this code. So I can see the predictions over here. So predictions and model resources and explanation is attributes, and there is an approximation error of 0.04 and output name is class. Visualize the feature attribution, and now till this is the last cell, and we'll see we have just only 5 minutes. I'm not sure whether this is going to execute properly or not, but I would like to execute and see. Okay, so you can pause the video and understand this code, or you can clone this repository and go at your own pace. So let me run this code. Okay, input image and feature attribution mask and overlaid attribution. So this is a prediction of dandelion, but I don't think this is a dandelion. This looks like a sunflower for me, but the confidence score is only 41%. So that means model is not good enough because of the errors that we have made during the process. The errors has happened. This is not right to my understanding, because this is saying dandelion, but this typically it is looks like a sunflower to me. Okay, and this is taking the images around it. You can see this overlaid attribution mask. Okay, but if you see, this is a prediction, this is actually failure prediction if you ask me. This is could be because of this step got failed, and we have got two different models, and one model is deployed as soon as this previous one is failed because of 900 seconds. But this is a good one of the good what I'd say lab to see how the failure is happening. Okay, even though our code is good, because of the infrastructure issues and delayed issues, we'll be able to see this failure. So I conclude my session, though this is a failed lab session, but the process is going to be the same. The process is not the failure one, but the output what we are expecting. The predicted class is dandelion, but the prediction should be the sunflower. Okay, I hope you understand why we got failed. Because of the deployment phase, there was some error during this cell execution, and this created the failure. Okay, thank you everyone and have a great day. Bye.